Section R.6, Synthetic Division. Let's first recall how to use long division to divide numbers. It may have been a while since you've done this, so let's just review a basic example. So if we want to divide 92 by 7, we put the 7 in the left corner, and we put the 92 underneath the division bar. And then remember, we want to look at the leftmost digit of 92, the 9, so we want to see how many times 7 goes into 9. So 7 goes into 9 once, so we put a 1 above, and then we multiply down. 1 times 7 is 7, write it underneath. Then we subtract, so 9 minus 7 is 2, then bring down the next 2. And then we repeat the process, so we want to see how many times does 7 go into 22. So 22 divided by 7, so 7 goes in 3 times evenly. So we multiply down 3 times 7, which gives us 21. Then we subtract. 22 minus 21 is 1. So we're left with that 1, which is our remainder. Remember, we'll say our remainder of 1. So if we want to check a division problem, we know we can do the opposite of division, which is multiplication. So if I multiply 7 times 13, and then add that remainder, that extra 1, I should get 92. And we can check that that does in fact work. Okay, so now let's recall long division of polynomials. If you remember, it's a very similar process, but we're using the polynomials instead of just the numbers. So remember, we're going to put our divisor, the thing we're dividing by, the x minus 3, in the left corner, just like we did with the 7 with the numbers. And then we're going to put our dividend, the 2x cubed minus x squared plus 3, underneath. Now, if you notice, we go from a power of 3 to a power of 2, and we skip x to the first power. So I'm going to put in a placeholder, a 0x. That'll help keep the terms lined up and make our division easier to do. So now we take the leftmost term of our divisor and divide it into the leftmost term of our dividend. So 2x cubed divided by x gives us 2x squared, so we write that above. Then we multiply down 2x squared times x, so 2x cubed, and then 2x squared times negative 3, which will give us negative 6x squared. And now we want to subtract, and don't forget to use parentheses here because we're subtracting both terms, not just the first one. And I like to change that subtraction to addition of the opposite so you don't forget to distribute to the 6x squared. That's the most common error that students tend to make on these, is forgetting to distribute to that second term. So I would strongly suggest that you change the subtraction to addition of the opposite. So now 2x squared plus 2x cubed plus negative 2x cubed, those add up to 0. So those cancel out. And then we've got our negative x squared plus 6x squared, which will give us our 5x squared. And now we're going to bring down the next term, the 0x. So now I'll repeat the process again. I take the leftmost term here, the 5x squared, and divide it by the leftmost term here, the x. So 5x squared divided by x will give us 5x. So we're going to add that at the top to our 2x squared. Now we multiply down 5x times x, 5x squared, and then 5x times negative 3, negative 15x. And now we do our subtraction again. Subtract the entire quantity, so use the parentheses, and then change your subtraction into addition of the opposite. So then when we add down the like terms, these add up to 0, 5x squared and negative 5x squared. And then we've got 0x plus 15x, which will give us our 15x here. And then we have one more term to bring down, the 3. So we'll bring down the 3, and we'll repeat the process again. The leftmost term is 15x divided by x, and we get 15. So we'll add our 15 at the top. And we'll multiply down again, 15 times x, 15x, and then 15 times negative 3, negative 45. So we subtract again the whole quantity using parentheses, and I like to change it to adding the opposite. So the 15x and the negative 15x add up to 0, those cancel. And then we've got 3 plus 45, which gives us 48. And now there's nothing else to bring down, and we can see that x will not divide into 48, so we know we're finished. And now that 48 is our remainder. So we can label, let's remind ourselves the terms here. So the answer to a division problem, we know is the quotient. We know what we're dividing into is the dividend. And the thing we're dividing by is the divisor, the x minus 3 in this case. And then we know down here we have our remainder of 48. So we could check our answer to the problem we just did using the division algorithm. Just like we did over here, we checked 92 divided by 7, so we checked it by multiplying 7 times 13, divisor times the quotient, and added the remainder, and we ended up with the dividend. We can do the same thing here with our polynomial. So let's just write out our division algorithm here generically. The dividend, the thing we start with, the thing we're dividing into, is going to equal product of the divisor and the quotient, and then we add on the remainder. So let's use this to check our answer to the polynomial division we just did. So if we take our divisor, x minus 3, and multiply it by our quotient, the 2x squared plus 5x plus 15, and we add on our remainder. If we multiply this out, if we distribute, so we'll distribute the x through all these terms, and then we'll distribute the negative 3 through all these terms. So we'll get 2x cubed plus 5x squared plus 15x minus 6x squared minus 15x minus 45, and then we add on that 48 for the remainder. So if we combine like terms here, this is going to simplify into 2x cubed minus x squared plus 3, which is in fact the dividend up here. That is what we started with, the polynomial we began with, that's our dividend. So we know it checks.